Today we will take this under the general organic chemistry part, the fourth topic, that is types of bond fission and the types of reagents and also the types of reactions. And today's class is types of reactions. This is really at a very important, and also with reference to the organic chemistry, the types of reactions, if you know it perfectly, most of the chapters the understanding in depth will become very easy. The types of reactions, as we have classified in the last class, they are defined into the addition, elimination, substitution, and the two other reactions are cycloadditions and rearrangements. However, the addition reactions are further classified based on the, because in the addition we are adding the two reagents, just like ethylene plus HCl. H is added, Cl is also added. But what adds first based on first attacking species? The addition is further classified into electrophilic addition, nucleophilic addition, and free radical addition. So, we take first electrophilic addition reaction. Electrophilic addition reaction. The reaction can be abbreviated like EAR, right, because electrophilic addition reaction. However, it is technically called, it is an addition reaction starting with electrophile. Therefore, it is notated, or the method of representation of this reaction is AE type of reaction. The examples are all alkenes and alkenes, alkenes and as well as alkynes, both undergo this type of the reactions. In fact, the direct question can be asked, what is the characteristic reaction of alkenes and alkynes? Electrophilic addition. Similarly, which compounds undergo electrophilic addition as a main reaction? Alkenes and the alkynes. A simple example we will take first. An ethylene, when treated with the HCl, it gives a ethyl chloride, CH3CH2Cl. Most of the addition reactions will have a favorable background. Why? Means the unsaturated compounds are becoming saturated. Saturation is the more stability. So, therefore, in the universally it is instability always leads to the stability. Therefore, the reactions of most of the addition reactions have a self driving force, that is the stabilization side reaction. So, therefore, there is no much heating or putting the elevated conditions like solvent usage or catalyst usage or some other external forces, not pressure, temperature, such things not necessary. Just you add, these two are gases. In fact, you can take the gas ethylene and the gaseous HCl directly you can add, you will get the ethyl chloride, or pass ethylene gas into the concentrated HCl solution that is dissolved in water, and then also you will get the ethyl chloride. So, one side H is added, it shows that the other side Cl is added, but the HCl will not add simultaneously in this reaction. It is studied, one part will be added first, the other part later, and it is also studied H will become into plus, Cl will become into minus. A cation and anion are going to add it. It is an ions addition reaction. It is studied. And ethylene, when it is passing in a gaseous state or in a solvent, when HCl, both ions are approaching this ethylene, say the Cl is coming closer to this one, ethylene is repelling the Cl, because ethylene is also considered as a electron rich molecule. Electron rich molecule. I can't say it is rich because there is a minus charge is there. No, it is not like that. Ethylene is rich when compared with alkanes. Alkanes have all CH and CC bonds. The bonds are perfectly shared and there is no excess nor deficiency of the electron cloud in the ethane. But whereas in ethylene, one is a sigma bond that is perfectly shared. The other bond, it is not totally overlapped, it is a partly overlapped pi bond. So it is a weak bond. By giving some energy, that is less energy, we can break. By breaking, what we will get? Electron. So therefore, we call this molecule as electron rich. If it so happens that the Cl minus comes forward first to attack, it will repel. Therefore, Cl minus will not attack. Whereas H plus is coming closer to the ethylene, then the H plus is allowed to attack. If it is in the gaseous state, there will be HCl molecule will be there without breaking. In the aqueous solutions, there will be a plus minus. Otherwise, the molecule will be there. H will have a delta plus and Cl will have a delta minus. If the molecule comes from the other side, Cl side, the reaction will be not taking place. But if it twists the other side, then the plus will be allowed to attack. As the plus comes closer and closer, the sigma bond opens into plus and minus. The first plus will be attacked. So let us call this is the step 1. In the step 1, H plus is attacking. So the H plus is an electrophile. So therefore, I call step 1 is the electrophile attacking step. After the H plus attacking, that means by taking the 2 electrons present in the pi bond will be taken by the H plus either this side or that side, because it is identical atmosphere. Whichever the side it comes, the 2 electrons will be polarized, and let us say the H is added on the left side. So you will get a bond like this. The other side CH2 will get a positive charge. Why so means both the electrons of pi is shifted this side and then the H plus is allowed to attack. After formation of minus, the H plus is allowed. So therefore, the CH2H is bond and CH2 plus is. Then we have a second step now. This is a step 2. In the step 2, Cl minus is allowed to attack. Now Cl is really negatively charged and there is a CH2 plus. So it is having positive charge, therefore it will attract, and the second step will become nicely the Cl plus attacks and a bond comes between the carbon and Cl. Cl is giving 2 electrons, carbon side no electron, but coordinate covalent bond is formed. After step 1, what you get is called intermediate species. It is called intermediate species. It is not compound, it is called species. Species means an item. Without having the total name, you can say it's a piece of the molecule. Actually, it's not total molecule. Still something is to be filled here. So it is not a molecule. Not, you can't say intermediate product also. Intermediate species we say. Generally, what you get after the step 1 is called intermediate species. Specifically, this intermediate species is plus charge on the carbon, therefore I call it as a carbocation, dash carbocation. Now in this case, this is ethyl carbocation. If I take propene, you get propyl carbocation, butyl carbocation and so on. Some carbocation is formed on which Cl minus will be attacked. So there are 2 steps are there. The first step electrophile, second step nucleophile. In fact, I have to say this reaction is electrophilic followed by nucleophilic addition reaction. But I am saying only electrophilic as if the nucleophile has no role at all. But nucleophile coming in the second step. So this classification is purely based on the attacking species. Whichever the attacking species, based on that I call. That doesn't mean second attacking species is there. It is there. So first electrophile followed by, if nucleophile comes first, then electrophile, I will say nucleophilic addition, in which electrophile comes as a second attacking. So first attacking H plus. Now why the electrophile only attacks first? The reason is here, the molecule is electron rich. Even if Cl minus happens to be attacking first, it will be repelled. And if HCl comes with a neutral molecule without opening also, when Cl minus comes, this is electron rich, that is also repulsion. So the polarization, after this polarization, a delta plus and delta minus will be there. As the H plus comes closer and closer, there will be an attraction developing. As a mutually, what happens when it comes closer and closer, the attraction develops and potential energy decreases. Where a H plus will having a loose bond with the pi bond is called pi complexes or Mesenheimer identified. If there is a good electron donating group is there and a good electron withdrawing groups are there in electrophile, a somewhat stable intermediate species. Before attacking, it has got a lowest potential energy state. At that, we call it as a pi complex formation. This is in the case of benzene, and with a strong electrophile like nitro, we can observe such a type of thing. But here, as the H plus comes closer and closer, this will be attracting and the bond will be breaking. As it comes closer and closer, this pi bond is also opening. So these two mutually takes place. The sigma bond opening with the help of some reagent neighboring closer by, when it comes, the sigma bond breaks, isn't it? That's called polarization in a sigma bond by a external group which is not connected temporarily in the proximity is called a inductomeric effect. Similarly, a pi bond polarization in presence of a reagent or an attacking species temporarily by not attached, but through the proximity, it induces and polarizes the pi bond is called electromeric effect. So in the alkene, we have a electromeric effect. In the sigma bond, we call a inductomeric effect. These two effects you can understand in a better way when once we understand what is a mesomeric effect and what is inductive effect. Those two are permanent effect. These two are temporary effects, analogous to the mesomeric effect, analogous to the inductive effect. In both the molecules, temporary effect is creating to open up the sigma bond and the pi bond, and the reaction takes place. Mutually, when they are coming closer, when the proximity becomes very close, then the polarization takes place, and then mutually that process or understanding will help to the progress of the reaction. So somehow the ethyl chloride is formed. There are two clear steps are there. Step 1 is electrophile, and that gives a intermediate carbocation, followed by the step 2, that is nucleophile. Now we have different aspects when the molecule becomes little bigger one, which side is one of that is Markovnikov rule, anti-Markovnikov rule, all such cases we have to discuss. But right now, alkenes undergo very fair reaction that H plus attacks one side, the other side carbocation is formed, and on that Cl minus is added. There are two steps are there, the product is formed. This is called what? Electrophilic addition reaction is a characteristic reaction of the alkenes.